Hello everyone, my name is Madeline Walsh, and today I will be talking about the behavior of light and how light rays can be used to create a photographic image with a pinhole camera. So how did people take photos without a digital camera? Well, before the creation of what we know today as the digital camera, images were etched into stone and later onto cloth or paper. In order to copy an image in the 1600s, a dark room or camera obscura was used to transfer images from the outside onto a piece of paper inside with a very small hole that was cut into one of the walls. As this process developed into the 1800s, they took this idea of a dark room and basically shrunk it down to create a portable camera obscura. And they did this with the use of a box. A small hole in one side of the box would import an inverted image onto the opposite wall. And as we have learned in past lessons, the image becomes inverted because light rays travel in straight lines. So what I wanted to do was construct an experiment to see this in action. To do so, I've constructed my own pinhole camera to determine how light travels and how light is used in the processing of images. So hopefully by the end of this presentation, there will be a better understanding of how this process works. As I've stated before, the project that I chose was to create a pinhole camera. A pinhole camera is a very simple camera that does not have a lens. So instead of a lens, this camera has a very small aperture or pinhole that will focus light into the surface behind it. The light will pass through this pinhole and project an inverted image onto the opposite side of the box. And what I found to be very interesting about these simple cameras is that they are still used today. They can be used for capturing the movement of the sun over long periods of time. They can be used for artistic reasons, and they can also be used for the safe observation of solar eclipses. And my family and I have actually made pinhole cameras in the past for the 2017 solar eclipse, which was really cool to see. And another thing that I found so interesting about these simple cameras is that they can actually develop images onto film paper. So the pinhole camera relies on the fact that light travels in straight lines. This principle is called the rectilinear theory of light. Once light is produced, it will continue to travel in a straight line until it hits something else. And the pinhole camera works because the small hole will accept very few rays from each point on the object. So if we decide to view a tree with our pinhole camera, the light will travel from the top of the tree straight through the pinhole and straight to the bottom of the image. And this will also happen with the bottom of the tree, which will show up at the top of the image, as well as the sides of the tree, which will also show up opposite on the image. And another thing to know about the pinhole camera is the relationship between the size of the pinhole and the distance from the hole to the image, which I will go into further detail later in this presentation. So here are the materials that I used for my experiment. During my research of how to create this camera, there were multiple ways on how to create it. There are even templates online if you wanted to create a box from scratch purposely for this pinhole camera, but I just chose to use a box that I had in my house already. The ones that I found online ranged from super simple with just a cereal box and aluminum foil to very complex with wood, film cartridges, old cameras, etc. But I opted for a camera that I could make with the materials that I already had in my house, which was a box, some wax paper, a needle to make the pinhole, aluminum foil, a sharp knife or scissors, duct tape and a bright light source, which I used the sun as my source. And excuse me, but also in this diagram that I put on here, you can see that the object appears on the opposite wall of the box and is inverted. And I just put the box that I made there. So moving on to the actual procedure, because of all the DIYs that I found online were so different from each other, it was kind of hard to find clear instructions for the materials that I had. So on this page in my presentation, I just listed out exactly what I did to make my camera. So first, I took my box and drew a line a few inches from the bottom to cut the box into two. And once the box was separated, I took the open end of one side and covered it with wax paper, making sure that it was tight with tape. And then I reconnected the two pieces so that the side with the wax paper almost acted as a divider in the middle of the box. And as you can see in my pictures, there is an open end as well as a closed end. And on the closed end of the box, you can see in the top left picture, I cut a 1 inch by 1 inch hole, which I then covered with aluminum foil, and then took a needle and pierced the foil right in the middle. And once this was done, you're pretty much ready to view some objects outside. And I chose to look at a flower pot as well as my dog Gus to view with my camera. And just as a side note, when looking through the open end of the camera, you want it to be as dark as possible. So to do this, you can either cup your hands around your face and the opening, or you can cover your head with something. I used a sweater, you could use a blanket. And as you can see, here are my images. The first one was my dog Gus. He's laying down, and as you can see, once I put the camera over him, his image actually changes. He looks like he's upside down and flipped over. And same thing happens with the flower pot that I looked at. You can see, I know these images aren't very clear, but you can see that the flower pot turned upside down and the colors have changed from right to left. So as I mentioned earlier in the presentation, the relationship between the size of the pinhole and the focal length will affect the image that will be formed. The resolution of the image depends on these two things. As the hole becomes smaller, diffraction will increasingly affect the image. And this figure to the left shows what is called the Airy function, which explains that most of the intensity of the light will be contained in a central maximum. So this is basically saying that there is a specific size limit for the pinhole to extract maximum image sharpness. I found that there was an equation that can be used to find the optimum pinhole size according to the focal length for maximum resolution, which is at the top right of this slide. And if you insert the focal length in millimeters, this equation should give you the hole size for maximum exposure. In the next slide, this graph just shows this relationship. And as you can see, as the focal length increases, so does the pinhole size. For my experiment, I used a 1 millimeter pinhole and found with this equation, as well as some trial and error, that the optimum focal length was about 800 millimeters or 2.6 feet. I expected the focal length for the maximum image sharpness to be a lot smaller than it was. I started out putting the camera very close to the object because I was not very confident that my camera would actually work with how small the pinhole was. However, after starting my trials, I realized that this was not the case. I just had to experiment with some different focal lengths. And as I said, I could still see the image about 4.5 to 5 feet away and about 1 foot away. But the clearest image, as you can see out of the 3 pictures that I added, the middle image was the clearest, which coincided with the graph on the previous page showing the optimum values of focal length and pinhole size. So to go a step further, I would like to eventually try to develop a photograph using a pinhole camera. There are ways at home to create developing solutions to visualize the photo that was shot with this simple camera. I actually tried to do this, and this is the image that I uploaded was my original camera that I had made. I tried to put a piece of photo paper in there and I made my own developing solution. However, I did not have the right paper, so no pictures developed. So I had to completely change it and just went back to looking at images. Unfortunately, I couldn't provide a photo, but if I had to do this experiment over, I think I would try a different shaped box, or I would try experimenting more with the size of the pinhole rather than just the focal length. But so some questions that might be asked, how can a pinhole camera develop a photo? Well, with photo paper, and I did not have the correct photo paper to do this, but the right photo paper, once exposed to light, will capture a latent image that can then be developed to form a visible image with some different developing solutions. And how do real cameras work? Well, different from this pinhole camera, which does not have a lens, um, a real camera has a lens so that when light bounces, it'll take all of those rays bouncing around into the glass and will redirect them to create a single sharp image. Which, of course, as I've said multiple times in this presentation, the pinhole camera does not have a lens, it just has a hole, but it can create a sharp image. Thank you so much for listening, and I hope you learned something in the process.